Welcome to Edupedia World Grade 10 Computer Science Video Lecture Series. I'm Upeka Vandibona, and from this episode we are going to discuss about the input and output streams in C++. Without data, computing is pointless. We need to get data into our program to do interesting computations, and we need to get the results out again. There are a variety of data sources and targets for output. If we don't watch out, we'll end up writing programs that can receive input only from a specific source and deliver output only to a specific output device. That may be acceptable for specialized applications such as digital camera or sensor for an engine fuel injector. But for more common tasks, we need a way to separate the way our program reads and writes from the actual input and output devices used. If we had to directly address each kind of device, we have to change our program each time a new screen or disk came on the market, or limit our users to the screens and disks we happen to like, and that would be absurd. Most modern operating systems separate the detailed handling of input and output devices into device drivers, and programs then access the device drivers through an input-output library that makes input-output from or to the different sources appear as similar as possible. Generally, the device drivers are deep in the operating system where most users don't see them, and the input-output library provides an abstraction of input-output so that the programmer doesn't have to think about the devices and device drivers. This concept is depicted in this illustration. When a model like this is used, input and output can be seen as streams of bytes handled by the input-output library. So our job as programmers of an application then becomes, first, to set up input-output streams to the appropriate data sources and destination, and second, to read and write from or to those streams. The details of how our stream are actually transmitted to or from the devices are dealt with by the input-output library and the device drivers. From the programmer's point of view, there are many different kinds of input and output. One classification is like this. First one, streams of data items. Usually they are to or from files, network connections, recording devices or display devices. The second one, interaction with a user at a keyboard. The third one is interactions with a user through a graphical interface. This classification isn't the only classification possible, and the distinction between the three kinds of input-output isn't as clear as it might appear. For example, if a stream of output characters happen to be an HTTP document aimed at a browser, the result looks remarkably like user interaction and can contain graphical elements. Conversely, the results of the interaction with a GUI, graphical user interface, may be presented to a program as a sequence of characters. However, this classification fits our tools. The first two kinds of input-output are provided by the C++ standard library IOstreams and supported rather directly by most operating systems. We have been using the IOstream library all through our course to use the keywords cin and cout. Let's talk more about this IOstream model. The C++ standard library provides the type iStream to deal with the streams of input and the type OStream to deal with the streams of output. We have used the standard iStream called cin and the standard OStream called cout. So we know the basics of how to use this part of the standard library, usually called as IOstream library. We first take the output stream, OStream. It turns the values of various types into character sequences and send those characters somewhere, such as the console, a file, the main memory, or another computer. We can represent an O stream graphically like this. So here you can see how it turns the values of various types into character sequences. The character C and the int array 12 and 34 and the int value 123. And also we can see how it sends those characters to somewhere else. The buffer is a data structure that the output stream uses internally to store the data you give it while communicating with the operating system. If you notice a delay between your writing to an output stream and the characters appearing at the destination, it is usually because they are still in the buffer. Buffering is important for performance, and performance is important if you deal with large amounts of data. Now let's move on to the input stream. Input stream also turns the character sequences into values of various types, and then get those characters from somewhere else, such as the console, a file, the memory, or another computer. This time, rather than sending, it is getting the characters. We can represent an input stream graphically like this. It is same like the previous illustration for the output stream. The difference is the direction of the arrows. As with an output stream, an input stream uses a buffer to communicate with the operating system. With an input stream, the buffering can be quite visible to the user. When you use an input stream that is attached to a keyboard, what you type is left in the buffer until you hit the enter key, which means the return or new line. And you can use the erase, which means the backspace key, to change your mind until you hit the enter. One of the major uses of output is to produce data for humans to read. Think of email messages, scholarly articles, web pages, billing records, business reports, contact lists, table of contents, etc. Therefore, output streams provide many features for formatting text to suit various tastes. Similarly, much input is written by humans or is formatted to make it easy for humans to read it. Therefore, input streams provide features for reading the kind of output produced by output streams. And with that, we are going to end up this episode. This is just the basics of the IOStream model. From the next episode, we will see how the IOStream model relates to the files of data. Thank you for watching and stay tuned on with Edupedia World.